Alright, welcome ladies and gentlemen, and welcome to another math video. Today we're going to be talking about volumes of prisms and cylinders. Volumes of prisms and cylinders, alright? So, the main thing you want to take away from today's lesson is that if you have some sort of prism or some sort of cylinder, the way that we are going to calculate the volume of these things is we want to find the volume of a face, or the area of a face, so we call this the base. We call this the base, and we're going to multiply that by the height. All right. Regardless of how we find the base, we're always just going to be finding the area of one side, of our object, and we're going to be multiplying it by the height of it. Find the area of one side of our object, multiply it by the height. Even if the shape is weird, we're going to find the area of the base times the overall height, or if you prefer, the length. But base times our height, 100% of the time. All right. So in order to calculate some bases, we want to be able to talk about some different type shapes. So first, a quick reminder of some basic shapes from when you were in like 7th grade. All right. We're going to take a rectangle first. I put it in the middle, but it's always going to be our length times our width. That'll give us the area of our rectangle. Okay? And if we cut a rectangle in half, we get a triangle. Okay? A triangle where we're going to take a lowercase b, so that's going to be an edge of our triangle, lowercase base of our triangle, times the height of our triangle. So that is going to be the height, or the base times the height of the triangle. But then, because we cut, essentially these two are the same thing, just talking about it using different letters, we're going to take this and then multiply this by 0.5. Or another way you may have seen it before is 1/2 times base times height, or base times height over 2. These are a bunch of different ways that you may have seen the area of a triangle written, either this way, whoops, or something like this. Okay? So base times height divided by 2 will be the area of a triangle. A rectangle is going to be length times width, and then if we go for a specific kind of rectangle, which is a square, where all the sides are the same length, instead of length times width, we're going to take a side and multiply it by itself. So a side squared is going to be our area for a square. So a shape you might not be familiar with how to find the area of, because you haven't had the tools to do it, would be the area of a regular shape. So like this would be an octagon. This would be like an octagon. If you have a regular sided shape, where you have the same angles, same side lengths for the entire shape, you would take and you would use the following formula. And there's a whole bunch of different ways you can go about finding these. But in my opinion, the easiest way is really just to memorize a formula. And to use this formula, we're going to use two letters. N is the number of sides, and S. S is the side length. Oh, there's only one N in length. S is the number of, or N is the number of sides, S is the side length. So if we have a weird shape, something that has more than 4 sides, the area of that figure is going to be equal to the number of sides times the side length squared. So you're going to square this side length first, divided by 4 times tangent of 180 degrees divided by the number of sides. Okay? So let's do a quick example of how to use this. So let's say that we have a hexagon. And we don't know much about this hexagon, but we do know that one of the sides, let's say it is side length is 7. Okay? So if we use this formula, the area of this hexagon is going to be equal to the number of sides times the side length squared over 4 times tangent of, times tangent of 180 degrees over the number of sides. So let's fill in the things that we know. Our area is going to be equal to, the number of sides on our shape is 6 times 7, which is our side length, squared, over 4 times tangent of 180 divided by the number of sides, which is 6. All right, so then we grab our handy dandy calculating machine, and we can put this straight in. Again, we go into our settings, make sure that we are in degree mode, make sure that degrees is filled in, because we are using degrees here. So we take and plug into Desmos just like it looks in our fraction. So because we're making a fraction, we're going to go ahead and we're going to put parentheses around the top. So 6 times 7, and we want to square that number. Finish our parentheses because we're done with the top. Divided by, it'll move down our fraction to the bottom. And best practices say to put the bottom in parentheses as well. So 4 times tangent, we go down to our functions menu, find our trig stuff. 4 times tangent of 180 degrees divided by 6. And then we get that the area of our hexagon here, our total area, is going to be 127.3 units, 0.3 square units. Okay, that's our area for this hexagon. It's a nice way that we can, it's a nice quick, just plug stuff into the equation type idea that we can solve for things. I would highly recommend writing down each of these and having these handy for everything that you work on when we're talking about shapes. Okay, have these guys handy. All right, and there's one last shape that we want to be able to find the area of, and that is a circle. We want to find the area of a circle, and that is going to be pi times r, which is our radius. Pi times our radius, and that's going to be squared. Okay. So again, make sure you have all of these formulas down, and all of these are going to be the areas of the bases for each of these objects. All right. So all of these we've been doing to find these bases. The height you should be able to identify from your figure. Okay, so let's do a few practice problems. All right, take a second and pause the video if you haven't already done so, and copy all of these formulas down. These are things that you're going to need. Also, if you hear some stuff in the back, my wife is making masks, so that is her sewing machine. So our first problem, let's find the area of let's find the volume of this cube. So we have to find our area. Our volume formula is always going to be volume equals some base times the height. Now, with a rectangle, you can pick either this to be the base, this to be the base, this to be the base. It doesn't matter what you pick for a rectangular prism for the base, as long as you just pick one and then find the area for that face, and then use the other one as the height. So I'm gonna pick this face here. All right. Now we know that that our base formula for a rectangle, we're going to use this guy, is going to be a length times a width. So for this very front face, I know that 10 centimeters is one of my numbers. Length or width doesn't really matter which one. And then since it's a rectangular prism, even though this 8 centimeters is measuring this back area, this back edge here, it also measures this edge here, as well as this edge here. So we know that this is a 10 by 8 rectangle. So we can plug that in for 10 by 8. So the area of our base, 10 times 8, is going to be 80 times our height, which our height is going to be this last number that we didn't use yet. That's going to be 12. So volume equals 80 times 12. Volume equals 80 times 12 is the same as, let's see, 8 times 10 is 800 plus 2 times 80 is 160, so 800 plus 160 says that our volume should be 960, and then we had centimeters, and since we multiplied centimeters times centimeters times centimeters, we get centimeters cubed, 900 cubic centimeters. Okay? So now, what is the volume of a cube with an edge length of 10 centimeters? I want you to try drawing the picture and see if you can come up with what the volume of a cube with the edge length of 10 centimeters is. Alright? Take a second, pause the recording, and when you come back, we'll have the answer. Alright, welcome back. Here's hoping you got 1,000. So, if I draw my cube, and I know that the edge length is 10 centimeters, since a cube is made up of all squares, I know that it's 10 centimeters from this back edge to this front edge. So this back edge is 10 centimeters long, but every edge on a cube is all the same length. So if we know that one of them is 10 centimeters, then so are all the rest of them. So if it's 10 centimeters that way, it's 10 centimeters that way, and 10 centimeters that way. So if we pick this as our face, we're gonna go ahead and say volume equals base times height. We're gonna pick this as our base, which means that we're gonna use this guy and this guy to calculate our base. That turns this one into our height. So to find our base is gonna be our side length squared, which our side length is 10 squared, times our height, which is also 10, so we'll have 10 squared times 10, which is just 100 times 10, so our total volume is equal to 1,000, and since we had centimeters again, centimeters cubed. Or you could write it as 1,000 cubic centimeters. Okay, so couple examples with rectangular prisms. Let's try a triangular prism now. So let's say we have a triangular prism, and we know that the base of our triangular prism, we're going to say, is 5 units long. We know that it is 9 units deep, and we know that the height, we're going to say this height is 4 units. 4 units tall. It kind of looks like an equilateral triangle, but just roll with it. All right. We know that the height is 4 units long. So we need to find our volume equals our base times our height. Okay? Take a second, see if you can come up with how you would attack this particular problem. Since we have a new shape for our base, we need to use a new formula for that base. So we're going to use this guy since we have a triangle. So our base calculation is going to be 1/2 times whatever original the base of our triangle is times the height of the triangle. So this is not the same height. This is the height of our prism. This is just our triangle. So we're going to take that times the height of the prism. Okay, so 1/2 base times height. Let's focus on just this triangle, just the triangle here first. So 1/2 times our base, which is 5, times our height, which is 4, gives us, if we multiply all those together, we're going to get 10 square units. Okay, let's say these are in inches. I apologize for leaving that out. Let's say these are in inches. So we're going to get 10 inches squared for our base times our height. Well, in this case, we know that our height is 9 inches, so we can go ahead and replace that h with a 9. 9 inches. So we have 10 inches times 9 inches. 10 times 9 is 90. Inches squared times inches gives us inches cubed. So that's how we can find the volume of this particular shape. Again, find the area of the base, multiply it by the height of the prism. Okay? So now let's try one with a less nice shape. Alright, so let's say for a quick second that I wasn't a horrible artist and someone just built a really, really long, perfectly pentagon-shaped house. So we want to find out how much volume of air is inside that house. So let's say that if we measure it across the front of the bottom of the house, we got 23 feet. And then we found out that it was 42 feet deep. Okay? So, to find the volume of this particular prism, again, it's going to be volume equals the area of our base times our height. And in this case, our height is going to be 42 feet, and our volume of our area of our base is going to be whatever the area of this pentagon on the front of our house is. So if we made a pentagon house, we're going to end up needing to use this n-gon formula, because we don't have a nice formula to find the area of a pentagon. So our volume is going to be equal to, our area of a pentagon is equal to the number of sides times the side length squared over 4 times tangent times 180 over the number of sides. And then we're going to take whatever number we get there and multiply it by our height. So let's fill in some numbers, let's fill in some values where they belong. Number of sides is going to be 5 times our side length is 23 feet. We're going to square that over 4 times tangent of 180 over our 5 sides times our height, which is 42. So once we have this, we don't have to do a whole bunch more. We can just hammer this straight into our calculating device. So again, we're going to put the top part of our fraction in parentheses. 5 times 23, which we are going to square 23 and just 23. Don't multiply it by 5 first. Divided by 4 times tangent. We go into our function menu, grab tangent of 180 divided by 5. Whoops. Divided by 5. So that'll give us our area. So if you want to write it out in a couple different steps, the area of our base is 910.13. So V equals 910.13 times 42. And our final volume is going to be this number times 42. Okay, so we have that whole thing typed into Desmos, and we're going to get 38225 point. I'm going to round to the nearest tenth. So since it's a 6 after that 5, we're going to say that is 0.6. And let me go ahead and throw a comma in here to make it easier to read. So this is 38,225.6 cubic feet, or feet cubed. Okay? So those are all the different types of prisms. Let's do a quick cylinder, and then we will be done for this video. All right, your math teacher's really glad that this video is coming to an end, because I took way more time on this like soup can thing than I probably should have. So I'm proud of it. Don't judge me too hard. I'm not an artist, but not too bad for your average everyday math teacher. Okay, so let's find some volumes. So a can of Campbell's soup. Let's say that this is like cream of mushroom soup or something. I don't know. But a can of cream of mushroom soup has the following dimensions. All right. So the diameter of our can is going to be 65 millimeters. To go from side to side. Okay. And then the height of our can is going to be 98 millimeters. So what is the volume of our can in cubic millimeters? All right. So take a second, see if you can figure out what it is. Remember, your volumes are always volume equals your base times your height. All right, welcome back. Here's hoping this is what you got for your solution. You might have a number that is 4 times this big, and that's okay. And mistakes are made to be fixed. So our formula is volume equals base times height, and our formula for the base is this guy: area equals pi times r squared. Okay. However, in this problem, so our formula for our base is pi r squared, and then we are just using the height of the can. However, in this problem, we're not given r. This 65 millimeters goes all the way across our circle. Our radius only wants to go halfway. So our radius wants to go halfway across our circle. All right, so we just want to start at the center, and we want to go from here to here. So we're going to take this 65 and cut it in half. Okay, our diameter is worth 2 radii. So 65 is going to be 2 times whatever our radius is. We're then going to divide both sides by 2 and get 32.5 is our radius. So now we plug in values into our volume equals base times height equation. We get that volume equals pi times our radius squared times 96. And when you hammer that into Desmos, where is the Desmos? There you are. When you hammer that into Desmos, pi times r squared times 96 gives us 318,557.5 millimeters cubed, cubic millimeters. Okay? So that's how these volume formulas are going to work. You'll have a worksheet on Classroom, so make sure you complete that. And I will talk at you guys during the Q&A session, or I'll just talk to you guys later. Bye, guys. Have a great one.